That's what I'm looking for. We're about ready. I swear I deleted this already. All right, here we go. I didn't review these. Watch me screw up again. Ah, life's great. Who would have known you could forget something after not doing it for 2 years? Try it someday. Science experiment. All right, here we go. You will see this in college a lot. If you take a college chemistry class, get ready to see the HA in the denominator. So you'll have, they'll put H plus right here. They don't usually do H3O. So H plus times A minus over HA, it shouldn't be scary. But in college, that's really, really how they communicate the Ka for an acid. All right? Don't panic about it. All right, so consider the equilibrium constant expression for the dissociation of a generic acid HA. A means an ion. Well, not like an ion. It means an ion. That was tricky for me. I don't know about you guys, but it's like, what am I talking about? Yeah, I would never, ever torture anyone by teaching them English. All right. This is math, which I don't ever want to teach math either. Rearranging this slightly becomes Ka equals H plus times A minus over HA. Taking the negative log of both sides, we get the negative log of Ka is the negative log of H3O plus the log of negative log of A minus over HA. I just took the log of everything. Don't write any of this down. Do not. Take that pencil off your paper, Sarai, right now. Okay, thank you. All right. So we can rearrange this to become pH equals pKa plus the log of B over A. Write that down. Soraya, pick up that pencil. This is the, there you go, grasp it. They're the same, aren't they? Well, it's the base, or this is the, A minus is the conjugate base. Acid, HA is the acid. I personally, I remember B over A. You'll see why I almost said that. Why? He does at home. He sits here and flirts with Nisha the whole time. And then he takes notes at home, and her grade goes down because of him. Yeah. Okay, here we go. I always memorize base over acid because I want you to remember the following term. Henderson-Hasselback is a bad A. Now, what I really want you to remember is David Hasselhoff is a bad A. And you're like, what? Who knows David Hasselhoff? Anybody? Yeah, the old man on Baywatch. So, from Knight Rider and what? I haven't seen that. Okay. The reason I want you to realize he's a bad A is so you don't flip this upside down. The most common mistake is you put this upside down. Hasselbach. But I just say it Hasselback. And really, I just say David Hasselhoff, even though that's not even remotely close to this person, but it doesn't matter. But this equation is really important and extremely useful. To find the pH, we can do an ice table with buffers, and we can do a ton of math there, or we can plug it into the David Hasselhoff equation and just roll with it. It's extremely nice. Okay, so have that in your notes. It looks almost like it's a decent day outside. We must not really have a meet today. Where's the snow?
I mean, it's raining a little
Oh, well, that's perfect because our track is beautiful when it's wet. You can't see all the hard water stains. You're like, oh, that looks brand new. Oh, never mind. Okay, here we go. So we want the following. Hold on. Let me make sure I remember how to do this before I do it. Yeah, not bad. Okay, it's easy. So it wants to know what is the pH of a buffer that is 0.012 m, so molarity, in lactic acid. So this is the acid, which is HC3H5O3, and 0.1 molar in sodium lactate. This, I mean, I really don't care about this. This is the conjugate base. So if you think about it, I have both a weak acid and a conjugate base. So I have a buffer. Probably.
Yeah, it is. But what's the
The conjugate base is the thing that came with the acid. It's this piece.
Oh, so it's always just whatever is not the H.
After the H. Caitlin.
So that lactate is the conjugate base of lactate.
Right.
That's okay.
Did I not say that?
Yeah, you did. I just
Okay.
you kind of went over.
So remember, let me erase this. A buffer happens. To be a buffer, you have to have two things happen. You have to have a weak base, and you need something that supplies the conjugate. Sorry, weak acid. Sorry, I'm an idiot. And a conjugate, I don't even know where I am there, base. Okay, the reason why it's a buffer, the weak acid neutralizes a base. I know that's an equal, but that means neutralize according to what I'm saying right now. And the conjugate base will neutralize an acid. If the solution can do both, we call it a buffered solution. Okay, now to figure out its pH, we plug it into Henderson-Hasselback equation. The Henderson-Hasselback said pH is equal to P. Okay, that's true. I'm going to just write pKa, which is the negative log of Ka. Plus or minus? All right, this gets confusing, so be careful. It is a plus, but it's a negative log. But we're gonna be all right. So the negative log of B over A. Was it? Did I write it wrong? Oh, no, it's not then. No, it's not. It's not a negative right there.
Oh, thank goodness.
Okay, sorry. We're good. Okay, that was my fault. Okay, then I'm going to plug everything in. I need P, which is negative log. I don't know why, don't ask. Ka. Plus, I'm going to take the log. The base is really the conjugate. What?
I was actually asking why is it red and black? I wasn't asking about P.
Well, that's what I said. I don't know why it turned that color.
Oh, they didn't.
Don't ask.
That's why you said I don't know. Oh, okay. Confusing time.
It's okay. Okay, what's the base? It's the thing that doesn't say acid, right? So it's the sodium lactate. So I come up here and it said that that was 0.1 molar, right? And the other one is 0.12. So make sure I put them in the right spot. So I had 0.10. I didn't need the zero, but whatever. Or 0.12. I kept that in the right order, correct? Yeah. Okay, then I just do math. Sorry, did you give me my calculator back? Yeah. Uh-huh. Yeah. Did you give it to me? Yeah. I'll tell you. Let me see the title. Oh, that's an insane book.
Is it a good book, actually?
Yeah, but it makes you, if you're not grateful to be in the life you are after reading that, then you are the worthless human being.
I actually have no for like that's.
That guy, holy cow.
So wait, but what roughly is the first 63 about like?
I don't know.
Actually, I feel like a worthless human being asking you
I
guys.
listened to the book on tape. I don't know.
Wow, that was a good study skill.
What?
I would not know
She
it.
said, read it.
She said, no, she said, well, yeah, she said to skim through the first couple sentences of every chapter.
Okay.
That won't be.
Okay, what did we get? Grace, what did we get? pH equals 7.7.
Yeah, it's just 7.7.
I'll go 3.8. Well, it'll be 3.9, wouldn't it?
No, because it's 3.77.
Okay. Can we just focus on chemistry for once? It's something this class really struggles on. Okay, pH of 3.8. Super not that hard, right? Okay, we will do this once in a while, but there's another layer that makes it, it's a second step, but it's not harder. I don't know if it's on the next slide or not. Here we go. Okay, that was just another practice. Do you want another practice? Okay. Yep. All right, so .15 molar HF, and I add 0.09 molar, sure, NaF.
Does it always have to be a weak acid?
Yep. For a buffer solution, you must have a weak acid and and its conjugate.
So it's
Oh, yeah.
will be
Okay, try it. Yes, Judah.
So this, we did a couple math things yesterday. Does this have anything to do with it?
Sort of, but no. What we did yesterday, math-wise, you don't even have to do. That was an ICE table that we can go through and do, or we can do Henderson-Hasselback.
Yeah, I took pictures, but I didn't write anything down because I wasn't 100% sure.
Yeah, and I screwed the math up at first anyway. In a few slides, we're going to do what my brain thought we were going to do, but we weren't there yet.
So you can do either or based on that.
Yeah, you can do either or, but this is the super easiest way.
And
If you-
then the conjugate base will always be strong. Or what?
No, it'll be the conjugate base of a weak acid. You'll never have to derive the Henderson-Hasselback. If you want to waste time doing that, you can.
Not like it's the ACT, all the time in the world, right?
Yeah, sure. No,
Yeah.
you have to go faster than the ACT.
Are you serious?
I'm super serious.
Where do we find it? You're only gonna have like 20 seconds to do this equation.
No, you have more time per problem, but the problems are harder.
Oh, well,
Why are we talking about the AP?
Okay. Yes, I'm not going to write out the equation. I'm just going to put the negative log of 1.8 times 10 to the negative 5. We okay with that? All right. And we had plus the log of, which one's the B? 0.09. And then we had 0.15. And we end up with what value?
4.5.
All right, I'll just stick with 4.5. Unless Judah wants to fight me. Okay. This is not that hard, right? Yes, tall man. Yeah, like the plan is to review, but when I spend 20 minutes a day telling you guys to shut up, we're not going to get a review.
Wait, we're gonna get a good review.
Yeah, sig figs are in our book. They're in the early videos. They're on the Khan Academy. They're on YouTube 200 times. We'll review them, but they are out there. They're actually really not that hard. All right.
Don't you just use the largest significant figure in the actual problem that gives you, so you would go to
I would do this math, and then really there was only one significant figure, so really it would be 5. But the AP test will never give you just crappy sig figs. Okay, moving on. Here we go. All right. Yes, they lose points for sig figs. We know that. We will review them. Let's do what we need to do today so we have time to review.
All right.
Here we go. This is the important part here. It's the pH after something's been added to the buffer. So it says we need to determine how the neutralization reaction affects the amount of weak acid and its conjugate base in a solution. These are pretty simple. So here we go. I have well, they're not simple, but they're not awful. I have a buffer solution, which I could calculate the pH to be 4.74. All right, this picture's kind of blurry. I don't know how well you can see it. Okay, screw it. It's going to stay just like that. It has 0.3 of the acetate, sodium acetate, and the acetic acid. It has 0.3 of both, which really means the pH can just be found by taking the Ka, because you take the log of the same number over the same number. The log of 1 is 0. So whatever, that doesn't matter if you know that math or not. You could type it in and your calculator would laugh inside, but you wouldn't hear it. It'd be fine. Okay, if I add 0.02 molars of NaOH, the pH will change. It should change a lot. It's only changing 0.06. It's only changing 0.06 because I have a buffer. Will someone take the negative log of 0.02 real quick? And so I'm going to take 14 minus 1.6 and I get 12.4. I'm adding something that has a pH of 12.4, but I'm only changing the pH 0.06. Like, that's a big deal. That's what buffers do. Okay, so I want you to think about the consequence here. If I add base, concentration of the acid, well, it's BHA. Will go down because the base neutralized the acid. So it's gone. Now, think about it the other way. Here I'm adding acid. If I add acid, all right, so I'm going to write acid because that would be confusing. Then the concentration of A minus goes down. Now, it really affects both. Because think about this. If I add acid, the amount of A minus went down, but the amount of HA goes up. So coming back here, the HA went down, so the A minus goes up. Here's the great news. They go up and down equal to each other. Okay, who raised a hand? Okay, sweet. All right. So we will use the Henderson-Hasselback equation to determine the new pH of the solution. All right, so pH equals the negative log of Ka, all right, plus the log of B over A. All we do is we take our initial of both of them and we either add or subtract their change based on what we added.
So if you add 0.2 of the acid, then you add 0.2 to the top, to the bottom, and then minus 0.2.
Yes. Well, we're going to do one. We're going to do one. What's that?
I said I'll figure it out when you do the equation.
Yeah. All that changes here is whoops, why did it do that? Whatever. We had an initial. I thought I changed to blue. We had an initial of a base over acid. I add something and it just changes that initial. Judah.
So if it says concentration base, if it says A minus goes up, base goes up, HA goes down. If we add
Yep.
A minus goes down, like acid.
It certainly can do both. And yes, you should know. All right, so here we go. This problem originally right here, it was that pH equals the pKa, all right, plus the log of my base over my acid. And they were both 0.3. I know the picture is blurry, but are you okay with that? Okay, and we just plugged it in. But now we've added 0.02 moles of H plus. So this is before. Let's do it after. pH will equal pKa plus the log. And now remember, this is my base. This is my acid. I am adding acid. Acid does what? It reacts with who? It reacts with the conjugate base. So the amount of conjugate base goes where? Down. So it was 0.3, but it's going to go down 0.02. Right? This was 0.3, but it's going to do what? Go up 0.02. That makes either no sense or sense. It makes sense. Okay. So now we plug them in and we'd be ready to roll. This one was, I don't think it even gave it to you. Right, I already have the answers. We could look up, I think it's 1.8, or was that HF? Ten to the negative 4? I don't know. And it doesn't matter because it already gave it to us. -5. I didn't worry about it because it already had the answers for me. Right here. You could, and it won't, but yeah, you could have. Okay. So does it sort of make sense that we added acid and the pH went down? Yeah, it should. So think about it at the end, because sometimes you do the math like you get it backwards, but double check like, hey, if I added an acid and it became more basic, oh, I must have done my things wrong. Okay. Sort of all right with this? Okay. Next up. So here we go. All right, so a buffer solution is formed by adding 0.5 mole of sodium acetate to 0.500 mole of acetic acid in 1 liter of water. Be careful on these, by the way. This gave you moles. It has to, we want to really deal with it in molarity, but we'll be okay because this one's in how much volume? 1 liter. So this one we can get away with, but double check. You know, it doesn't usually screw your life over that way, but it certainly can. Okay. So a buffer, it's whatever. To 1 liter of water, what is the pH of the solution at equilibrium? So that is just straight Henderson-Hasselback. Will you attack this question right here? Here's the Ka. Yeah. So they make you read that and the jungle the same year. And they want you people to turn out normal. No wonder you all have stress.
Yeah.
Rock was saying that language arts is pretty much advanced Holocaust studies.
Okay. I love the jungle. That's a fantastic book. Depressing as all get out, but good. Okay, keep going. Math, math, math.
Somebody died in my room last night. I can't remember what it was.
It's all right. We don't have time to worry about it. Right. This is just the negative log of the Ka, which is what answer? All right. Fair enough. Okay. What would be the addition after the, sorry, what would be the pH after the addition of 20 milliliters of 0.2 molar NaOH? Okay, so now we do have to convert these to moles. So 0.02 times 0.2 is 0.004, is that right? The volume times the molarity. This has got to be in liters. Is it not 0.004? Okay. All right. Now, this is base, right? Acid down, base up. So we have pH equals the negative log of the same thing, 1.8 times 10 to the negative 5 plus log of base goes up, right? 0.504 and under is point, and then we're ready.
Wait, I'm confused. Why do we have to do
To find out how many moles were involved. Yeah, it's just one, so it doesn't matter, but we need to, this doesn't give me an exact number I could use. I need to know how it affects, but since it's in one, we can live with it. Go ahead.
Doesn't this kind of like the law of 0.7, doesn't that kind of fit into your about how that's so small, why would it even make a difference?
Yeah, but in a buffer calculation, they want you to know that the buffer is doing such a good job, that there is such a little change. Even though we added fairly concentrated base, no, not a lot of change happened.
Yeah, it went from 4.74
4 point what? 7.5. So look, 20 milliliters of 0.2 molar base is actually a significant amount. If I added that to just water, we're going to have like a 12 something pH. But since there was a buffer, the change was almost zero. Almost zero. Okay, you do the bottom one on your own. One o'clock or 1:10? I should remember by now. Okay, thanks, Kayla.
Oh, that's when I'm leaving.
Oh,
Today's Friday, right?
it dang well better be Friday. So help me.
Oh, you're
Yeah. You get out at 1.
When do you
Should I
sleep
go
in?
right at 1?
When do you sleep unusually? Like if you can't sleep in? Like how late do you sleep in?
I don't usually sleep past 7 ever.
Really? Do you like wake up naturally? If you
Yeah. It's just my bladder. It says, Tom, you got to go to the bathroom. What? Sucks. From the overall. From the overall. Don't do it from the second one. It's been the longest year of my life. I don't know about you guys. Okay. What did we get? 4 point what? Okay, so even though we added fairly concentrated H plus or hydrochloric acid, the pH didn't change much at all because we have a buffer. Buffers are extremely good at neutralizing things. All right. Let me double check. These are all where we're at.
I'm leaving. Goodbye.
Get out of here.
What? Are you? I thought we were here.
Okay, this will be our final thing.
Sorry, did you say you wanted to solve this?
Yeah, solve all parts of these if you can that fast. All right, we'll see you out there. I heard that, Garrett. We are co-head coaches. But he took half the day off. I did not take the day off because I don't feel like I need to. What? To get ready. Yeah, he's out there right now. Him and Scott Walker took half days. If I taught AP in the morning, I might have taken a half day. You're welcome. I just needed to see Cooper today. If you listen to that book on tape, it's actually his voice. It's really cool. At least what I listen to. Being 8-year-old and having to murder people?
Syria or like Syria.
No. Nope.
Number two, I always use the same thing when it's the same thing as number one. Like, sorry.
Yeah. So the number one is just calculating the pH of the buffer. Number two, it's after an addition. Number three, it's just strong, finding it for the strong base and comparing. Yes. Yeah, that's a yes. Tons of them have multiple, yes, for sure.
Ever heard of South Sudan?
Definitely not worth the noise.
I just said, sorry. I just said the country ever had 2 civil wars because I was hoping that we weren't due up for another.
I don't think we'll have a civil war ever again.
But are humans very predictable?
Yeah.
It seems very predictable.
We're like too organized to have one.
No.
In the US. Like I feel like we have a lot of disagreements, but we're not too organized.
I don't think
I feel like countries that don't have one, their government is super organized. They don't have a lot of like stuff in order, you know?
Look at who our past few presidents have been.
Yeah, but the system of electing a president, the system of like. Oh.
Yeah, I guess it's more organized than ours.
Okay, should I assume everyone's done with all 5 parts? Not a chance in hell. Thank you. The rest of you should actually focus for a minute.
Yeah, you added. Yeah. Oh, that's right. I always think that pH.
Is anyone even on number 4?
I am.
Okay, good. I'm going to give you one more minute. Well, I'm going to give you 36 seconds and then we're going to do them. Like we're not going to work through them because we don't have time. We're going to talk about them and what it's trying to let you, like what you see. Okay, here we go. Number 1, what was the pH? 3.5 sounds good to me. Okay, number 2, it's the same buffer, but now we are adding NaOH, right? So that means the base goes up, the acid goes down. So we end up with something probably more basic than 3.5. 3.7. Okay, that should make sense. We add base, it becomes more basic. Okay, number 3, sometimes kids are like, I don't know how to do that one, that's hard. If it's NaOH, that's strong. So we literally just take the negative log of the initial concentration. Negative log of 0.08 is equal to. Okay. Oh, yeah, good. Thank you for saving me there. So it's 14 minus that answer, because it was really the POH we just found, is a 12.9. So what this is trying to illustrate to you is we had a 3.5, we added a 12.9, but it only went to 3.7 because it's an effective what? Buffer. Okay, number 4, we add acid, so it should get a lower number. What was that pH? 3.4. And then what's the negative log of 0.04? 1.4. So we did that, and then it has this, and this is super common on the AP test. It says compare the pH found in problem 4. So you would say something about how, even though we added something very acidic, the pH did not change because the solution was a buffer, and the H plus reacted with the, what even was this? The H minus. So the H plus reacted with the F minus to produce the weak acid of HF. This one you could say that the OH minus reacted with the I don't know, sorry, the HF acid plus the OH minus, and that neutralized it as well. It just made more F minus and water. Yes, John.
So when we were finding the pH of the acid, 1.4, can we not subtract it from 4?
No, because technically, and thank you, Tolman, again, technically this equation we were finding the POH. This equation we were finding the pH, because this one was the concentration of OH. Negative log means the P means negative log of the OH. So that's why we had to find that, because pH is equal to 14 minus POH. Right, then it's just a straight. Kind of okay on buffers? All right, I will most likely put a few things on Canvas, nothing hard, but some things to keep your mind going in the next week. I'm beyond busy that week, so it won't be a lot, but it will see something. Probably math.